Young people, welcome back. BMB in the house, y'all. Taking care of chapter 8, lesson 7. We are deep into this chapter, guys. Let's see what they need us to do. The learning objective: factor trinomials of the form ax² plus bx plus c. Second objective, of course, solve equations of the form ax² plus bx plus c equals 0. All right. So swap back. Students will be able to solve complex trinomials. Those are my words, right? Also, students will be able to factor complex trinomials. Hopefully you've been with us, meaning that you've been in chapter 8 for a little bit and you know the difference between a simple trinomial and a complex trinomial. Understanding that a simple trinomial has a equaling 1, the invisible one. So what we're going to have today, guys, in the form of ax² plus bx plus c, you're going to see it. You're going to love it. Let's get it started. All right, guys, lovely handout to start off. Already gone. And again, guys, as I said before, there we go. Solving ax² plus bx plus c equals 0. So the directions: factor each polynomial, if possible. That's important, right? You can't always factor something. If the polynomial can now be factored using integers, write prime. So first one, 2x² plus 5x plus 2. Now, we're going to use some techniques that I've been using in other lessons before this one. As we go through it, guys, I'm just going to talk about what I know and explain it for you, right? We're going to label A, B, and C. And by labeling A, B, and C is now going to allow me to use what I like to call the diamond. In the top of the diamond, we have A times C, and the bottom of the diamond, we have B. So we've done this before, doing it a little bit more. So for this trinomial, 4 in the top, 5 in the bottom. What multiplies can be 4, but adds up to 5. 4 and 1. So now I'm going to use the box. So we've had the box many times, guys, and slowing down, making sure you get what's going to happen from the diamond to the box. First term, first square, 2x². And last term, last square, 2. Now we're going to add 4x and 1x into the box. And then we're actually going to factor out and figure out what goes on the top and what goes on the left so that we can get the two binomials that multiply. So factoring up what goes into 2x² and 1x. Factoring up what goes into 2 and also goes into 4x. Well, just 2. Now we're going to go to the side and we're going to have 2x. And what goes on the bottom, just 1. So again, we're factoring the greatest common factors for those two terms. Check it, meaning 1x times 2x is 2x². 2 times 2x is 4x. 2 times 1 is 2. And of course, 1 times 1x is 1x. So we found the two binomials that we need so that when multiply give us 2x² plus 5x plus 2. Those two binomials are x plus 2 and 2x plus 1. Guys, definitely pause it, go back and watch it again. But we got a lot of these, so we're going to go into number 2 after we recognize what we're doing. So, slowing down, and again, those two binomials, x plus 2, multiplied by 2x plus 1, is how we got the trinomial 2x² plus 5x plus 2. Yeah. So, let's do it again. Number 2, 3n squared plus 5n plus 2. Identify your coefficients and constant. In other words, identify your A, which is 3, your B, which is 5, and C, which is 2, right? And now, I call it a diamond, don't ask. You know, we lowered it down to just an X, but what goes in the top, what goes in the bottom. 3 times 2 give me the top, 5 in the bottom. Multiplies and give me 6, but adds up to 5, 3, and 2. And you notice I've already put the variable with it because when I transfer from that graphic organizer, I call it a diamond, to the box, first term, first square, last term, last square. Middle term, we broke into two different ones, 3n and 2n, right? So 3 plus 2 gives me 5. So that's that diagonal that adds up to the middle term. But now we're factoring. And again, your factor skills need to be on point. So 3n comes out of 3n squared, and 3n comes out of 3n. 2 comes out of 2n, and 2 comes out of 2. And then, of course, moving upward, we took an n, and we took a 1. So factoring, guys, is definitely something you gotta kind of have. We can slow down, but we've got quite a few of these. So I'm gonna go ahead and explain it again. Inside of that box, 3n squared and 3n. As you go out of the box, you're pulling out the greatest common factor. 2n and 2, you pulled out a 2. And then we pulled it out going up as well. And we'll see it again, guys. So let's get it in here. All right, I like that. Nice and big. So 3 has 2 t squared plus 9t minus 5. What is my A? What is my B? What is my C? I'm going to use those to set up a graphic organizer to factor the complex trinomial. And the top of that, I got A times C, which is negative 10. And the bottom of that, I got 9. Now, what multiplies to me negative 10, but it adds up to 9? Well, I need a positive and a negative. Uh-oh. I need a positive and a negative because the only way to multiply to get a negative is multiplying two different signs. So negative 1t and positive 10t will multiply to give you negative 10. But when you add them, you'll get a positive 9. So that variable is so that you know it's going to add up to the middle term. So again, first square, first box. Sorry, first square, first term, last square, last term. Middle term is the diagonal, right? And it has to add up to the middle term. So that's why the 10 was positive and the 1 was negative. And the more you do these, the better. Oh, we're factoring out, we're factoring out. One more to go. And let's get a pause. Now, the reason why we're pausing, guys, is because this is a critical moment of understanding the factoring. So earlier on, we talked about factor trees, greatest common factor. So literally, when you create that box with the four squares, right? You're realizing that I'm creating this box so I can factor out of it what number goes in. Because again, when we're checking it, we're basically taking the outside numbers and making sure they multiply to get that inside, right? So let's see that. On the outside, left, t and 5. Okay, on the top, 2t and negative 1. So we do the check. We say t times 2t, yes, it's 2t squared. 5 times 2t is 10t. Got it. Now, the right side of the box, right? T times negative 1, negative 1t. And 5 times negative 1 is negative 5. So everything is working out, but you don't have to guess. You don't have to be like, oh, well, what is it? No, we factor out. So when I say factor out, the two bottom squares, what goes into 10 and goes into 5? Well, 5. So I'm taking a 5 out. That's why there's a 5 on the bottom left outside. Now again, the top two numbers, 2t squared and negative 1t. Well, you can take a 1 out of everything, so we never call 1 a factor. But what about the t's? The first square has 2 t's. 2 times t times t, 2t squared. So it has 2 t's. The second one's got 1 t, negative 1 times t. So I can factor out a t from both. And that's why I have t and 5 on the outside left. Now on the top, as you go up, right? Well, again, negative 5 and negative 1. Well, and a t, of course, but the other one doesn't have a t, so I can't factor out a t. I can't factor out anything except 1. So yes, there will be a time where they don't share a common factor except 1. And notice, I knew it had to be negative though, because of the negative 5, the last term in the trinomial. And then of course, as we go up on the two left terms, 2t squared and 10t, well, what goes into 10 and also goes into 2? 2. All right, and I always say pick the smaller number, like 2. You know 2 goes into itself. Well, 2 going to 10? Yes. Then you know you can pull out a 2. And of course, 2 t's. So take a t out, because you can take 1 from the top square and 1 from the bottom square, and hopefully this is making sense, right? That's why you're here. So it will make sense. So point of confusion is gone. Guys, let's get this started because we're going to see a whole lot more of these, and I won't always slow down to discuss the factoring out your common factor. All right, let's get it started. All right, guys, so final answer. 2t minus 1 all times t plus 5. And again, you can always do a check, guys. You would do the distributive property. You can do FOIL, or you can use the box like we did, but we already got the box and all that. So number 5, I have 2t squared minus 11t plus 15. So first thing I recognize is a is 2, b is negative 11, and c is 15. Ooh, so again, in the top of my diamond is a times c, and the bottom of my diamond is b. Now I keep saying diamond, it's just that x we made. There it is, 30 and negative 11. So now my brain starts thinking, multiplies to give me a positive and adds up to a negative. Gotta be 2 negatives. So negative 5 and negative 6 add up to negative 11. But when multiplied, those two numbers can be positive 30. So I found the numbers that I need. What do I do with them? Put them in the box. They're your diagonals. The first term, 2t squared, goes in the first box. Last term, 15 goes in the bottom one. And now I'm going to fill it in with what I got. I got negative 5 out the t. And I got negative 6 out the t. So you notice in number 3, I put it in the diamond. I didn't put it in number 5, but it's my understanding. So let's factor out. What goes into 6 and 2? 2. What goes into 5 and 15? 5. And of course, I don't forget the t, because if I've got 2 t's and the other term has 1 t, then I can take one of them away. Take one from him, take one from him, and only leaves 1 t left, right? So factoring again. Same thing going across this way, 2t squared and negative 5t. Well, 2 and negative 5 don't have a common factor, but they both share a t, the variable t, so you pull the t out. You see those negatives, right? Very important. And watch me check it now. 1t times negative 5, 1t times 2t, negative 3 times 2t, and negative 3 times negative 5. So those little blue checks are literally checks to make sure that how I did this problem, how I factored it, actually worked. Because you will make a mistake with a negative or a positive, or even 2 times 5, 8, 15, right? So little things like that can cause you to just make a mistake. So that's why we gotta do 24 of them, right? Well, we'll start solving them in a minute. Let's get caught up, guys. Number 7, a is 2, b is 1, and c is negative 1. Oops, but it's okay. Let's see if I catch it though, right? Because I caught it. See, y'all, see. My editor, he was probably gonna think I forgot that. I forget that. We got it. But a times c, so negative 2 on top. B is 1. Recognizing that b is actually invisible in this one. 2y squared plus y minus 1. That b is an invisible 1. So again, multiplies give me negative 2, but adds up to negative 1. We got it. It's already there for you, right? Fill it in the box. And again, guys, this is where if you're good at factoring, you kind of go pretty fast. You see 2y and 2y squared, you come up, I'm taking out a 2y. I see negative 1 and negative 1y. As I come up, I can take out a negative 1. Now I'm going that way, right? Factoring out. 2y squared, negative 1y, can only take a y. And then 2y and negative 1. Again, negative 1, you can't take anything from negative 1 except for 1. The only thing you can take from 2 is 2, but that one doesn't have a 2, it only has a 1, so of course we put a 1 on the outside. No blue checks this time, guys, but why not? Y times 2y, 2y squared, y times negative 1y, negative 1y. I'm sorry, y times negative 1 is negative 1y, y times 1 times 2y is 2y, and 1 times negative 1 is negative 1. So you can see where the tongue-tied and twisting, yeah, there's a lot of variables. There's a lot of terms, but that's because we're already on number 7, guys. So as we get to number 9, and we'll keep number 7 up there for our notes and our practice, because we're doing the same thing over and over and over. Repetition, repetition, repetition. All right, labeling my A, B, and C. setting up a times c in the top, so that would be negative 12. B in the bottom. You notice I haven't wrote that a long time. Wrote that the first time, and now I'm coming back to it at number 9, so you know where those values are coming from. Multiplies give me negative 12, but adds up to negative 3. What ways can I get 12 when multiplying? 1 times 12, 2 times 6, and 3 times 4. Now, I know that the difference of 1 and 12 is 11. The difference of 2 and 6 is 4, and the difference of 3 and 4 is 1. I need them to have a difference of 3. None of them have a difference of 3. So since none of them have a difference of 3, what I end up recognizing, guys, is I can't really factor this one, I don't believe. And the reason why is, remember early on when it said, write prime. So if it's prime, meaning, what can you take out of 7? Nothing except for 7. What can I take out of 3? Nothing except for 3, because they're prime numbers. So in that trinomial, we write prime. Number 10 though, it ain't gonna be prime. A little bigger values, guys. Don't get nervous. Have that calculator handy. Be prepared to just know the process. And in this one, guys, it looks like A times C will give me negative 16. That's gonna go to the top. The B is 15, so that's gonna go on the bottom. My mind does this. I say, hold on, those numbers are very close. Negative 16 and 15. 16, what about 1? I think 1 can work, because if it's a negative 16 at the top, that means one number needs to be positive and the other number needs to be negative. So a positive 16 and a negative 1. If I add 16 and negative 1, I get a positive 15. And when I multiply those two, I get negative 16. So again, guys, the more you do this, the better. I always gave my students like 25 simple trinomials to do, just so they got in the habit, right? Then we move to these, the complex. So first square, first term. Last square, last term. Filling in the middle diagonal with the answer to our diamond. Don't forget to add your variable. Oh, there's my arrows. Factor out. The smaller number is 4. 4 goes into 4 and 4 goes into 16. Factor out. I got a 1. The only thing you can take from a 1 is a 1, so put a 1. And I like that I already put negative. We'll see why, because we'll do some checks. Now going up, again, I got a 1. Only thing that can go into 1 is 1. What about the B? Well, because top term had 2 B's, bottom one had 1, so I can take 1 of those out. And again, 4 and 16, well, we already kind of did that one, but doing it again. Verifying that my signs are in the right place, meaning that the negative 1, not a negative 4, that does change your answer. So, did our check, we got our blue check sitting there. And we got a great answer, guys. So, number 12, moving on. 6q squared minus 13q plus 6. And again, guys, A, B, and C. I'm gonna go ahead and prepare to factor this by multiplying A times C, gives me 36, B is negative 13. So again, hold on. If the top number is positive and the bottom number is negative, then I need 2 negatives. Because a negative times a negative gives me a positive, hence positive 36. A negative plus a negative is more negatives. So 9 and 4 is 13, we're good. Now, I don't know why I got that box ready without getting the box to get the answer, right? So I'm boxing 2 binomials with the anticipation of getting an answer. First term, 6q squared. Last term, 6. Middle terms, again, whether I put 9q here or if I put negative 4q there, it doesn't change too much, but you'll get it if you do it on your own, right? You'll kind of see that. But again, no yellow arrow going out, but 3 goes into 6 and 3 goes into 9, so I'm taking out 3, factoring out 3. 4 and 6, 2 goes into 4, 2 goes into 6, so I'm factoring it out. And now as we go up, again, they both have q's, so I'm taking a q out. And again, with 9 and 6 again, but guys, let's verify the inside, 3q and 2q. Ah, you see that, 6q squared. But 3q and negative 3 give me the negative 9q. Right? It's important. Then of course, negative 2 times 2 cubed gives me negative 4 cubed. And then the negative 2 times negative 3 gives me that bottom square of positive 6. And that's why, guys, repetition, repetition. If you did 3 of these, it wouldn't be that helpful. All right, let's take that. It would be helpful, but you wouldn't see all the variances. You wouldn't see all the hiccups. You wouldn't see some of the challenges. So you got to do more than one. You got to do them over and over until the curveballs, the things that get you to a point of confusion, you can get over it, right? So let's see if we have any points of confusion with 14. Are you confused with your A, B, and C? No? Good. What goes in the top? Whoa, really? Yes. 10 times negative 15. What goes in the bottom? You got it. Now again, guys, for somebody like me, I can figure it out, but how do you figure it out, right? What are you gonna do to figure out what multiplies, give me a negative 150, but adds up to negative 19? I like it. I know one's negative, one's positive. Only way to multiply is get a negative, different signs. And now, of course, let's talk about it. What are we gonna talk about? 1 times 150, 2 times 75, 3 times 50. All I'm doing is, throwing out those values, those two numbers that I can multiply to give me 150. But hopefully, your teacher can give you what's called a graphic organizer, a reference sheet, a chart, or something that will help you figure out these two integers that multiply to give you 150 and add up to a negative 19. That's what I mean by, you'll get a curveball. So, if you haven't realized yet, I'm stalling, giving you some time, but let's see if we can get this one here. Excuse me. So, 2w and 5w. Why? Because it gives me 10, w squared. Now, the middle has to add up to a negative 19. Well, we already know one's positive, one's negative, so let's try 3 and 5. Now, why do I like 3 and 5? Well, because 3 times 5 is negative 15 or positive 15. Hold on. There we go, negative 5, right? So 5 times a negative 5 is negative 25. 3 times 2 is 6w. Does that add up to negative 19w? It does. So that can be called guess and check. Because I didn't fill out the diamond. I never got the two sides. The numbers were too big. I didn't know. I played with the box. And this is where if we were in class, I'd call you up to the front, give you one of those Jolly Ranchers on my desk and say, go to work and figure out how to get the answer to the inside of that box. All right. So guys, a lot of factoring. Now we're gonna jump into factoring to solve. So what I need you to remember is the zero product property. Meaning if two things are multiplied that equal 0, either both or one of those must be 0. So in this problem, number 15, I recognize since it's a 2x squared plus 7x plus 3, I know it's plus plus. If you saw video 8.2 or 8.3, I had so many videos I forget, then you recognize that plus 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 minus or minus minus when factoring trinomials. So 2 times 3 is 6, middle term is 7. Multiplies give me 6, adds up to 7, 6 and 1. Add the variable x, so 6x and 1x for my diagonals. And of course, we haven't forgot last term, last box, first term, first box. Now factor on out. We're gonna go up first or to the side first. We went up. And remember, if you see a 1, you know it has to, you can't take anything from a 1. So that's why it's 1x, even though we don't see the 1, it's invisible. And then of course, went kind of faster. 3 and 6, well 3 goes into 3, 3 goes into 6, and then again for that bottom again, going outward, only thing that goes into 1 is 1, so there we go. And I love the little white checks to make sure that you know what I know. So part 2 of solving it now. We factored it, we got our two binomials, x plus 3, and we got 2x plus 1. Set each binomial equal to 0. That's our zero product rule. So either x plus 3 equals 0, so therefore x equals negative 3, or 2x plus 1 equals 0, and we solve the two-step and got x is equal to negative 1. So now, guys, here's what we're going to do. We're going to check it. Because it says check your solutions. So we're going to check our solutions. Right? We plugged in -3 because we said x equals -3. 2 times 9, because -3 squared is 9. And 7 times -3 is -21. 18 plus 3. Just, associative property of addition. Commutative property of addition, I apologize. No, associative property. One of those properties, right? 18 plus 3 is 21, and 21 minus 21 is 0. What the hell? It checks. But we gotta check both, right? So here's where kids be like, I don't want to check a fraction, and they skip it and be like, oh, don't do that. So 2 times the -1/2 squared would be 2 times 1/4, because -1/2 times -1/2 is 1/4. Then of course, half of 7 is -7/2, or a negative half times 7 is -7/2. So I just basically made it into a fraction. And again, guys, this is where your teacher would say, come see me at lunch. We definitely want to go over this. You want to have this skill. Because if you can get the answer and you get stuck here solving it because it's a fraction, we want to get that out of your system, right? Fractions are always going to be there, and we just want to make sure that you can navigate them. So 2 plus 12 is 14, right? I can now have the same denominator. And then -14 plus 14 would give you 0. So guys, take a picture, write it down, because that's a beautiful check, and it's gone already. Because we got more to do. And we already been here 22 minutes, 23 minutes, 24 minutes, 25 minutes. I don't know, but we've been here a while. Number 19, 6h, wait, 19, did I skip 17? I don't know what happened, but let's do it. 6h squared plus 8h plus 2. A times C in the top. You notice I'm not labeling A, B, and C anymore? You should though, right? Multiplies give me 12 and adds up to 8 with 6 and 2. So 6h and 2h is what's going to be in there for my middle terms, because they add up to 8h. Remember I used to show the equal and the 8 middle term? And again, guys, factoring out. As I went up, it's showing it right there. 6h and 6h squared. So I can pull out a 6h. 2h and 2, well, they both share a 2, but they both don't share an h. And then going this way, right? Hold up. What's going on? Oh, guys. Wait! Something's not right. And that's why I love doing this with you guys. GCF, greatest common factor. So, the bearded math brother forgot to do step 1. Check for a GCF. You get so into the routine, you forget to do what you were taught. So, is there a greatest common factor? Yes, 2. So we pull out a 2 and now our whole trinomial changes. I gotta erase the whole diamond, because if I don't pull out the 2, then I don't have the correct A. A is equal to 3, B is equal to 4, and C is equal to 1, because I have a GCF. Don't you love it when you make a mistake? If you do make a mistake, boy, come give me some of what you got. Because I know I make mistakes, and it makes me a better teacher, person, human. Yes, I'm human, not a robot. Multiplies to give me, 3 adds up to 4. We're getting all types of little boo-boos in this one, huh? So, of course, 3 and 1. First term. And again, guys, I'm going to the factored one. So 3h squared for the first term. Last term is 1. 3h and 1h. And again, guys, is this a 1? Then, of course, only 1 can come out of it. 3h squared and 3h, well, they both share a 3, and they both share an h. So I took out a 3h. And then, of course, coming out this way, guys, 3 is prime, 1 is prime. So really easy, hopefully, in your factoring skills. Don't forget your 2 on the outside. First binomial, 3h plus 1. Second binomial, 1h plus 1. And it's still equal to 0. So now I actually have 2 that equals 0. No. 3h plus 1 that equals 0. And h plus 1 that equals 0. So start where you want. H equals -1. Or start at the 2-step. 3h equals -1. Divide both sides by 3, and h would equal -1/3. Over here, subtract 1 from both sides, and h is equal to -1. So 2 solutions. First one, -1/3, and my second solution, -1. So definitely check on your own, but I think you guys want me to do more problems. I think you do. So let's see if we can at least get one or two more in here. No more checks. Let's just get her in. As I mentioned earlier, guys, if you're jumping right to this video, chapter 8, lesson 7, there's a lot that I'm talking about and showing that is from some of the other videos in the chapter, because we build on what we do. And right now, we need to build on this. It doesn't equal 0. Since it doesn't equal 0, I gotta make it equal 0. We did that in some prior lessons. So subtract 6y from both sides. You notice I put it under the correct term, the like term. 18y minus 6y now gives me 12y. Again, looking for a GCF. Yeah, 3 goes into 9, 3 goes into 12, and 3 goes into 12. So now 3 on the outside, and my new trinomial, 3y squared plus 4y minus 4, and it still equals 0. Now I can tell you that my a is not 9, my a is 3. My b is 4, my c is negative 4. So a times c gives me a negative 12. B in the bottom multiplies give me a negative, has to be a positive and a negative. So 6 and negative 2. And when I add 6 and negative 2, I get a positive 4. So as we started this process 20 minutes ago, I'm still using the first box for the first term, last box for the last term, using the answer to the diamond to fill in the middle term. That's where the negative 2y and the positive 6y came. And now, guys, again, factoring. So do 3 and 2 share factor? No, so I pull out a 1. Does 6 and 4 share factor? Yes, 2. So that's why I have a 2 on the bottom left there. And then, of course, going up, 3 and 6, they share a factor of 3. And, of course, 2 and 4 we talked about. Don't forget your variables. And, of course, don't forget to solve it. So this is only step 1. Step 2 now is to use a zero product property, where I know one of these has to equal 0. Because when I multiply 3 times that parentheses, and whatever that is times the next parentheses, they gotta equal 0. Ooh, I'm gonna fit that in there? No, I'm not. Give me some room. All right, we're gonna rewrite that. My OCD kicks in. Sometimes I have to rewrite it, y'all. Here we go. And last binomial, y minus 2 equals 0. So wherever you want to start, with the 2-step or the 1-step, looks like we're starting with the 1-step, y equals a positive 2. The 2-step, add 2 to both sides and divide by the coefficient 3. So 3y is equal to 2, y is equal to 2/3. Beautiful. Guys, I really would like to get another one in. You know, like I do, the further down we get on these handouts, the more challenging the problems can be. So let's get to the ultimate challenge, right? In other words, let's do the last one if we can. This ain't the last one. 23, 10, b squared minus 15b is equal to 8b. Pause. I gotta pause. Now, the reason I gotta pause is, I know a student right now that I had that would be yelling, "Bearded Math Brother, where are my steps? I need steps. What's the first step? I don't see the first step." You're right. You do need steps. Step 1, set your equation equal to 0. Okay, I can type all this out and put, my editor's not gonna do all that. But put it in the comments. We are making these videos for you guys. Whatever we can do so that you understand this better, trust me, we can try and get that out there for you. But when I look at number 23, the first thing I recognize is step 1 doesn't equal 0. Step 2, factor out a GCF. Step 3, factor the trinomial into 2 binomials. So as I've been talking about what to do, there hasn't been a list of steps, right? So next time, in the comments, in the chats, say, "Bearded Math Brother, how about some steps for these high, challenging problems?" Let's get it going. So subtract 8b from both sides and add 12 to both sides. Now recognize where I put those. For me, I get that 10b squared and then negative 23b plus 12. Nothing complicated for me, but again, you might need to do that a few times, recognizing your like terms. Step 2, check for a GCF. None. Now, I didn't do that throughout the handout, but I used to require that. I would make kids write GCF equals none because it gets you in the habit. Now, if the middle term is negative and the third term is positive, then I need a negative negative. So A is 10, B is negative 12, and B is negative 23, and C is 12. So multiplies give me 120, but adds up to negative 23. So I need a negative negative. We already got that in the two binomials, right? So what multiplies to give me a negative, what adds up to give me a negative 23 but multiplies? I don't know. So I'm just gonna start guessing and checking. Let's use the box. First term is 10b squared. Last term is 12. We need it to add up to negative 23. So those two are gonna be negative. So how do I get 10b squared? Let's try 2 times 5. 2b times 5b. Now how do I get 12 though? And remember, it's gotta be a negative and a negative, right? So 2 times 6, 1 times 12, 4 times 3. I got all these options to get 12. So let's try negative 3 and negative 4. And let's see how the inside works out for us. 2 times negative 3. 2b times negative 3, negative 6b. Negative 4 times 5b, negative 20b. Hold on a second. I was so close. That does not add up to 23. It adds up to 26. So let me try again. First guess, wrong. Second guess, let's see, because we're guessing and checking, right? What other way is going to get 12? Well, should I try 4 and 3 again? Should I try 2 and 6? Well, why don't I just flip those? Will flipping those help? Because I like 4 and 3. But what if the 3 is down here next to the 2b? Now I get negative 15b. And then, of course, 2b times 4. Don't forget the negative. It needs to be at the 4 and the 3. I know it's not there right now, but y'all know what's up. Guess what? 8 and 15, 23. So we found it, guys, in my second guess, right? So you notice both times when I had a times C that was a large number, like 120 or 150, I just started guessing. I just started figuring it out, which is okay, all right? That is perfectly okay. We're gonna go on over to the handout there and finish it out. 5b minus 4 is equal to 0, or 2b minus 3 is equal to 0. So they're both 2 steps, and there we go, guys. First one, add 3 to both sides, divided by 2, and I get a positive 3/2. The other one, I have to add 4 to both sides, so 5b is equal to 4, and then we're going to divide both sides by 5, and I get 4/5. So, guys, all I can say is outstanding. Outstanding. Look forward to seeing you guys in the next video. We are almost done with chapter 8, and don't worry, I'm going to be here for the whole book.